Hello, Johnny again, and here we are. I think it's tutorial 33. I think I've lost count. Anyway, this is the next video in the sort of physics engine explanation, convert it into a practical game. So, and I said we was going to be doing a clone of Lunar Lander, called it Neptune Lander, just for the sake of it. And what we did in the previous tutorial for the physics engine, we did the gauges that we're going to use to show speed of speed of velocity and horizontal speed. But in this one, what we're going to do is we're going to apply the physics engine to the Lunar Lander in a basic way, just so we can understand what's going on, and then take it from there. But before we're going to do that, we need to understand how sprites work. So what I've done is I've done some slides on all the registry of the VIC II chip. And so we'll concentrate more on the sprite side of it, because that's what we're going to use. So the VIC II chip starts at address D1000 or 53248, and the first 16 or 16 bytes of the VIC addressing system is the X and Y coordinates of the 8 hardware sprites that are available to us out of the box. And so each one of those sprites has an X position and a Y position, and they come in the pairs. So you got offset 0 and 1, that's sprite 0, 2 and 3, sprite 1, and so on. And then you'll see on offset 16 here, which is 32764, that we have a high bit for the X position. And you'll see what I mean by that later on when we start messing around with the sprite. So the first 16 bytes are basically to put the sprite on the screen at a specific XY location. 32765 or offset 17 is more to do with the video, turning bitmap mode on, or turning it off, having 24 or 25 rows, or do the vertical pixel scrolling. We're not going to do the vertical pixel scrolling in this game, but that'll be something that we'll be talking about in future videos. Offset 18 is the raster line scan register, where you can read, and it tells you which raster line it's currently on, and if you write to it, you can actually force where the raster line is. And because a TV screen has more than 255 rows, offset 17 bit 7, or the high bit, is also part of the raster interrupt number. So you can because that will then give you 512 lines to play with. Then we've got 2 registries for reading the light pen, which we're not going to look at because we're not going to do any. But register 21 is going to be important to us, because this is where you turn on and off the sprites. So you can turn it on and off by this register. And basically what happens is each bit specifies whether that byte's on. So bit 0 will be sprite 0, bit 1, sprite 1, and so on until you get to bit 7, which is for sprite 7. And it's just basically you put a 1 in to make it appear and a 0 in to turn it off. Offset 22 or 53270 That's some more screen registers where it's number of columns, multicolor mode, and also the horizontal scrolling system. Then you've got register 23, which is the sprite vertical expansion byte, and each bit of that byte will tell that corresponding sprite to be double the vertical size. So it allows you to, make the sprites bigger, but you've only got the two sizes, small and large, and that's it. Offset 24 or 53272 is some more screen addressing and character addressing, which we'll not go into because we're just doing the sprites here, but we'll do it later on in another video for other things. And then offset 25, this is where we can test where there's been a collision, and we can test whether there's been a sprite on sprite collision or sprite on data collision, as well as the light pen and raster scan, but we're not bothered about those two. But the sprite on sprite collision and the sprite on data collision, they're the things that we're going to be wanting to look at when we start filling out the game, and those two bits represent the whether it has collided or not. So if there's a 1 in there, that means it's collided. If there's a 0 in there, that means it hasn't. The next byte, which is registered to offset 26, is turning on those detection points. So if you put a 1 in it, it turns on the collision detection. If you put a 0 on it, turns it off. Register 27, that's your sprite priority. So basically what that does is, if you put a 1 in it, it means the sprite goes behind the text on the screen. If it's a 0 in it, by default it will be in front of the text on the screen, and we'll have a bit of a play with that. Offset 28, that turns on the multicolor mode of the sprite. So if you put a turn on the corresponding bit, that will turn on the multicolor mode for the corresponding sprite, and the colors are defined in the next slide. And then we've got offset 29, which is horizontal expansion, and that makes the sprite twice as wide. So just like the vertical, you can make the sprite be 4 times bigger, I think it is, when you put them both on. It's 4 times bigger. Register 30, that is where you can when there's been a sprite on sprite collision, you will find which two sprites have collided, because there'll be a 1 in the corresponding bit for that sprite. So if you've got, say, sprite 1 and that collides with sprite 6, then bit 1 will be set and bit 6 will be set. And then you've got the next one, which is the data collision with the sprite. So same thing again, but what will happen is the sprite will only have the sprite that's collided with the data, or the text in the screen, or anything like that, will have a corresponding 1 in it. And when it's read, both those registers will reset. So they'll stay with the 1s in until they're read, and then when they're read, they get reset. And then the final set of let's see, that's 14 registers, are basically just the colour. So you've got 53280, which everybody will know is the background colour, and only the least significant bits are set. So the least significant nibble, which is 4 bits, is set. The top end nibble is always set to 1, will always be 1. So when you read the background colour, it will always be 111 and then the colour of the background. Same with the border. I got them the wrong way around. 53281 is the background, 53280 is the border, which everybody will know. Then you've got the background 2 colours or 3 colours, which is for the multicolour mode on the screen. Then you've got the 2 sprite multicolours. So all 7 sprites will use their own colour as well as the 2 multicolours. And then you've got the 7 sprite colours. So that's basically the VIC chip in a nutshell, and we can go into more detail in later videos when we explore these things. So we're going to make this sprite, and the eagle-eyed ones of you will know that this is almost exactly the same as the Commodore 64 Lunar Lander sprite, which they're technically right because I borrowed it, and we're going to build this sprite inside the program and be able to use it within the basic system. And then these sprites, the explosion sprites, I'm going to borrow from the person who wrote the new book that's out, and which you can buy from Amazon. It's called Retro Game Dev by Derek Norris, and I've borrowed his exploding sprites out of the game that he's created in the shoot 'em up. So we'll be borrowing those sprites, and I'll show you how to import them into the system. Right, back to the physics engine. This is what we're going to do. We have to represent this curve in the computer. Now normally what happens is you say, right, I'm going to work out the velocity of and the position of the lander every second, and so you end up with something like this. So we work it out there, then we work it out there, then we work it out there, and this will allow us to do it in manageable chunks. So what I'm going to do is we're going to start writing the code. I'm going to do it in BASIC, very simple, because I want to get the philosophy of the physics engine across in a way that you guys can understand, and then we'll take it on a bit further than that, where we'll convert it to assembly code and tighten it up and stuff like that. So here's CBM Prod Studio. So we're going to create a new project. It's going to be Commodore 64 one. It's going to be called Lunar. No, it's not. Neptune Lander. And we're going to put it in GitHub. There we go, GitHub. So I'm going to put in there. In fact, I won't create it there. Create it here. Right. New folder. Neptune Lander. So, here we go. Neptune Lander. And it's written by me. Next. Yep, that'll do. Create. So now we've created the solution, and we're going to add a new file, and this file is going to be called Neptune Lander.bas. There we go. So what we're going to do is we're going to write some basic lines of code, and to basically put the lander on the screen. So the first thing we're going to do is we're going to activate the sprite. So if we go back to the chip registry system, here we go. To activate the sprite, we need, where is it? There it is. It's that one there, isn't it? No? That's the high byte activation. Enabling, here we go. 53269. So I'm going to poke 53269, and we're going to poke it with 1. So that's going to be sprite 0, because effectively yeah, that's bit 0, which equals sprite 0. So that's going to turn sprite 0 on. So if we run this now, there you go. So we've turned it on, but we can't see it. That is because by default the X and Y position will be 0, 0, which is somewhere over here. So what we need to do is then we need to give it some X and Y positions. So let's see. So if we say Y equals, and we'll say 60 to start with, and then poke, and sprite 0's Y register is 53249. So 53249, and we're going to say poke that with Y, and we'll do the X one as well. So X equals 60, and poke 53248, because X was before Y, of sprite 0 with X, and then we'll give it a colour. So poke, right, sprite 0 colour register, sprite 0 is 53287, so poke 53287, and for simplicity we'll make it black. Right, let's run that and see what we get. There we go, there's the sprite, one black blob. So we've got the sprite there. Right, so we need to make it. We need to make the sprite. Okay, so it's dead easy to put sprites in. Go into the Project Explorer, right click on sprite data, add new file, and so Neptune, whoops, Neptune Lander. Click OK, and then we double click on it, and we can now make our lander. So what we need to do is we need to create a new sprite that gives us our matrix. So go back to the slide. So we're talking 1, 2, 3 a dot, and then right, so go back, and what we basically do is 1, 2, 3 dot, and then from the end space dot space space dot. So space dot space space dot. Right, so what I'm going to do is I am going to make this a bit easier to because I don't want to be swapping from the slide, so I'm going to be making it a bit easier, and I'm going to do a bit of a trick, which is to use a snipping tool. Say new, grab it, put that over there, bring the sprite editor back so I can swap like this. Right then, so then we've got 2 here, and oh, in fact it's 3, and then 2, and then 2 there, and then in the middle, second row down, we've got all the way across. Right, I'm going to carry on doing this because it's going to be boring for you guys doing it, but I'll speed everything up so you can see what I'm doing, and I'll talk to you on the other side. Right then. Well, that looks the same. I don't think it's any different. Doesn't look any different. Right. So that's the sprite done. So we're going to save it. So, but the problem is now we've got to get that sprite data into the basic program. And so what we're going to do is we're going to try and export it. So we're going to export the sprite. So export, and we're going to say to listing. And so we're going to say basic data, start at line 1000, increasing by line 10. I'm going to put 3 bytes per line. It's going to be in decimal and uppercase. And we're specifying the sprite 1 because that's the only one we've got. Alright, we could say generate only the included one, but we'll say sprite 1. So click OK. Oh, it doesn't like it. Let's do that then. Right, so if we close that, we should have some lines of code. There we go. So there's our first sprite. There's our Lander sprite in data. Now, as you notice when we run the program, it's just a black blob. So we've got to put the sprite into memory that we can address. And the way the sprites work out, the way the sprite works out where its memory is it divides the entire memory by 64 bytes, and then you tell it where the index of that 64th block of sprites are. So what we're going to do is we're going to say, so we're going to poke, and we're going to poke 2040, which is for the pointer for sprite 0. Now that is not within the VIC II register. That is just a bit of memory tucked away somewhere where Commodore looked to see their memory usage. They found that there was 8 bytes just nestled just after the screen screen area, and because those 8 bytes were not being used for anything, because we couldn't put basic there and all that, they used it as their sprite pointers. And the way it works out is you tell it, right, I want to be on sprite pointer 192. Now the memory address for sprite pointer 192 you have to work out. Now the calculation is that it's the sprite pointer times by 64. So in this case it's 192 times by 64, which equals, right, okay, get my calculator out. So 192 times 64, so that's 12288. Okay, so that means 12288. So that means we've got to put this data in this memory location plus. So there, that means now we've got to read the data. So we've got 63 data points. So we'll do a for loop for I equals. Let's see, it's going to be naught in it. For I equals 0 to 63. Read A, and then we're going to poke A. Now we're going to poke 12288 plus I, comma, with the value A. Next I. So that should read the sprite memory and put it in. That should read the sprite data and put it in the memory location we've specified for index 192. So best thing to do now is let's run it and see if it does it. So before we got it to do a black blob. So let's see if we can see if we've getting to point it the right way. So we're going to run it again. And there you go. There's our sprite. And as you can see, by default it's over the top of the text by default, but you can set it to be behind, but we're not going to do that yet. Out of data? What do you mean out of data? 0 to 63. That's right. What do you mean out of data? 3, 6, 9, 12, 15, 18, 20. We'll put an end in there somewhere. 999. 999. And I think it was going into the data and trying to read it again. Let's just make sure. Yes. Out of data. In line 60. So it's trying to read one more character. So let's do 62 because it's only 63 characters, I think. Not 64. I think there's only 63 characters in the sprite, not 64. There we go. Bingo. So we got our sprite on the screen, but as you can see it's not doing anything. So this is where we start implementing the physics engine. So what we're going to do is we are going to right then, after I recorded this video, as you can see I've cut into it, it was 50 odd minutes long. So what I've decided to do is I've decided to cut it here. So this video is about an overview of the VIC II chip and how to create a basic sprite in BASIC and how to set it up. Because it was like 20 minutes, we're 20 minutes into this video, so I thought it was a good place to cut it. So in the next video is the remainder of the video where we actually implement the basic mechanics of the physics engine into the Lunar Lander. So with that, please like if you like this video, press the thumbs down if you dislike it. If you haven't subscribed to my channel, please do so, and if you'd like to become a patron, that would be much appreciated. So I will see you in part 2 of this video next week. Take care, bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.